All right, ladies and gentlemen, when it comes to figuring out polarity and intermolecular forces, the easiest thing to do is to check out this flow chart you have, okay? The top section doesn't really have anything to do with polarity or intermolecular forces. It just tells you what type of bond you have, which type of intramolecular force. So that first part is our last chapter. Our newest chapter has this little section that says polarity. Are there any lone pairs on the central atom? If the answer is yes, you have something that's polar. If the answer is no, you have to ask a second question. Are all the surrounding atoms the same? If they are, you have something that's nonpolar. If they are not, it is polar. Just to let you know exactly what polar and nonpolar means, polar means you have something with an uneven sharing of electrons. Okay? That means that one side of it is positive and the other side of it is negative, okay? And when you have that, you can have different atoms attracting to each other, so that's kind of cool. Nonpolar is when you have even sharing of electrons, okay? So you don't have any positive side or negative side. Okay, so the first thing you have to do in order to figure out if something is polar or nonpolar, before you even look at the flow chart, which you should keep with you, and there are only 2 questions. I think you can handle it. The first thing you have to do, is draw the Lewis structure. So we're going to do, let's do maybe 4. We'll do water, and we'll do oxygen, and we'll do CH4, and we'll do, how about CH4I? Okay? So the first thing that has to happen for all of this is I would start with water. I draw it, I put the O in the middle, and it looks kind of like this. And if you're having issues drawing Lewis dot structures, go back to the videos. And the first question I ask from here is, are there lone pairs on the central atom? I guess you got to find the central atom. That would be oxygen. Are there lone pairs? There's a set there and a set there, so guess what, ladies and gentlemen? This is polar. Easy, breezy, lemon squeezy. Let's try the next one. Oxygen. Oxygen has a double bond. Okay, and that's what oxygen looks like when you draw it. And so we go back to the chart. Are there lone pairs on the central atom? Holy moly, there's not even a central atom. So what I'm going to do is I'm going to see if this is even. So I'm going to draw kind of a line right through it. Is it the same on each side? Sure is. That means it's nonpolar. It's an even sharing. So this is nonpolar. If you have something that's exactly the same, like oxygen, nitrogen, chlorine, fluorine, any of the Hunkelbriefs, those are going to be nonpolar. Okay? CH4. So I'm going to draw CH4. It looks kind of like this. Okay? And we got this nice CH4 thing going on. I don't know if you can see the flow chart anymore, but the flow chart says, are there lone pairs on the central atom? Well, let's look. Our central atom here is carbon, and this pair of electrons goes to this hydrogen. This pair goes with this one, this one. There are no lone pairs. So the second question is, are all the surrounding atoms the same? Hydrogen, 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 hydrogen? Sure are, so guess what? That's yes, though that's non-polar. Easy breezy, lemon squeezy. Our last one is CH4I, except for, you know what, I screwed up. I want it to be CH3I, because carbon can only have 4 bonds. So I put carbon in the middle, and I make sure it has 3 H's. And then it has to have an I, and I has all these valence electrons around it. And the question still is the same. Are there lone pairs on the central atom? It's right here. The answer is no. All of those electrons are being shared. So then the question becomes, number 2, question 2, are all surrounding atoms the same? Is the answer yes? Oh, no, they're not. So it's no, so this is polar. So ladies and gentlemen, that is how you deal with polar versus nonpolar.